So I'm just going to go back to where we left it. So I was showing that this page, which does principal coordinate analysis and ANOVA, is not available in the local host, unfortunately. But if you are running in the web app, you could still open this page. Since I have not loaded any data in the web app one, I'm not having anything here. So I would just go back to the local host. And then, yeah, you have options to play around with some of the multivariate statistics, like clustering using hierarchical clustering algorithm. And it also shows you nice heat map. For example, like you see, these samples are entirely belonging to another cluster tree. And let me get into the heat map quickly. Okay, maybe it was showing the full version for me yesterday when I tried it in the night. Okay, just to show you how it looked like for me, I saved it so that I can show it. So this is how it looked like for me yesterday, with all the samples loaded in and all your features. Yeah, something if you find it useful, you do that with the heat map. And also you could download the, go back. So if you click in this arrow button, you would exit the full screen, and it's taking a while. Yeah. And with the photo or the camera one, you could download this plot. And before downloading this plot, in the image export format here, you have different formats available. You could choose. If you choose like SVG format, you could take it to the Illustrator, like it is in vector graphics. And then if you want, for example, PNG format, it just sets it. And also we have the p-value correction, like different types of corrections with Conferoni, pH, Hall's discovery corrections methods when you are doing your univariate statistics. And here I'm going to use pH statistics, and we can just go perform ANOVA test now. It takes a while, I guess, so that once we do the ANOVA, you can take the results with the significant, and you can see that he's struggling. Run. And yeah, once you're in the ANOVA and you perform your ANOVA and you take your significant results, and then you can again go back into Cytoscape and also visualize what are the significant features that I saw from my statistical test. And you could choose which attribute you want to choose. Then you're basically looking into the mean of the different groups. I'm choosing sample area to run my ANOVA. Are you all here on the same page, like in the ANOVA? Nice. So here I have all these features that you see in red are all your significant features, and these are all your non-significant features. This is with the F statistics that you change value as a result of your ANOVA test. And here you could, in the ANOVA result table, you could already see all the metabolite features and then their corresponding p-values and the p-corrected values. Like you can see that my p-value correction is still Bonferroni, and if I change any of my correction method, it would recalculate it again. Or either I have to run it to make sure that it is doing it correct. I have to run it again, which I'm doing. And then what you see here, which you get after like the ANOVA test, is the two options to look for comparison. Because with ANOVA tests, when you are going for multiple groups, even if one group is significantly different from the other group, it would call it as a significant feature. So in order to make sure, you want to go further into to know like if it is significant. So this is what you they call as post-hoc test, which we give here in two keys comparison. You could also do this in a t-test, which is also doing pretty much the same thing, and you choose your two groups and you go for it. Okay, nice. I have the results, and this is the results I downloaded as well, which you could also do. I'm just doing it, and it's downloaded as just a TSV file without any formats. You could open it with a text editor, Excel, anything. I'm just opening it in Excel. Yes. And you see your metabolite values and all those, pre-corrected and significant values and non-significant values. So you could just save it in CSV format or TXT format. And yeah, Daniel would talk about this in the next session. For example, here you already see that one of the compound imetsapyr is under like the significant features. So going back to the app, you could also see it as box plot formats in these significant metabolite section, and you could play around with the significant features, and you see the names, the annotated names of some of them. And yeah, I was also finding some of the names, maybe first one, vision energy, fortunately. Okay, this is all I wanted to show here. But like I already downloaded the one for the next session, and I put it in the FBMN stats folder in the resource and the Eco-Metabolomics drive, as I showed earlier. There you could find it in the FBMN stats. There I already have some of the files here, for example, the ANOVA significant metabolites. And we also have the importance scores from random forest. Since we did one univariate test, you could also go into two key comparison. Maybe I will also run that, and then we could move to multivariate statistics. For example, in this plot, we could see visually that, okay, Mission Bay, the compound, the particular compound is found higher. In this one, it is significantly higher than the others. So it says that it is like, it gets a significant score. So if I want to go further, let's say between Mission Bay and probably in like the other site, Torrey Pines, I could just choose it here. Which is Mission Bay, and I have to choose one another site. In the meantime, if you want to have a look, you could also look into this about sections, which already have some information about tests and with some dummy data set, what happens underneath the actual calculation. Oh, it's here. Nice. So we have the volcano plot, two key plot. with Mission Bay and Torrey Pines. The one on one side is significantly found abundant in one group, whereas the one on the other side is like found on the other group. But to make sure, I will just check with Mission Bay and Torrey Pines as group A and group B, which is also what we have here. So I assume this is higher in Mission A and this is higher in Torrey Pines. If you want to go recheck it, you could also go back into your ANOVA table, the box plot table, and make sure for a particular metabolite to see if, for example, like here, you see 41617, it is okay, it is significant, I guess so. So we could just go back, quickly look into this box plot. 4167 is the first unique ID. Oh yeah. 167. And it shows you, okay, it was Mission Bay, which was found higher. And then for that particular metabolite, you see relatively very little contribution from the other location, which is Torrey Pines. So yeah, with this for univariate statistics, and I just wanted to quickly show you guys into random forest, one supervised analysis. With Josh also we covered all the basics of the test data set and a train data set, all those things. But once again, to give a quick introduction in the random forest is that it basically splits your data into train and test data sets. It keeps 70% of your data set as train data and 30 is left for testing. And in the train data set, it already creates many little trees, which is through bootstrapping, which is your subset trees. And then it performs the classification on that little trees that it has and get the prediction score. So you give the classification attribute, which could be any group. For here, we have choose the sample area. It's like basically asking random forest, tell me what are the features that you learned to improve your model so that you could classify them among different areas or groups. So once the classification is done, and you get the prediction score and you average all these predictions, group all these little trees into this forest, and that is what we call as the overall random forest prediction. I expanded it. Then as a result, so I would just run in the meantime. I have sample area. I'm choosing attribute sample area. And then we don't, usually for these models, you need to perform hyperparameter tuning. There are so many parameters that you need to tune, but we wanted to also keep it simple. So we wanted to just put little parameters because it will also make it heavy to run on Streamlit Cloud. But then if you're doing it in your Python scripts, it gives you more flexibility to do this hyperparameter. Not just Python scripts, like in scripts like Python or R scripts, it gives you more flexibility, these hyperparameter tuning. And then like you can just give the number of trees, like 100 as of now, and we can check with the results if my number of trees is enough to make that prediction. And then you have this out of bag error, which is basically the set of samples that it left out of the bag as a part of its algorithm while trying to do the predictions. It is sort of an internal validation that the algorithm does while building a tree. It puts some samples out of the bag and then does runs a random forest on this set, and then it also does an internal validation on this out of the sample, leftover sample that we had. So what we need is that we want the line to lower down, and we can see like, we could choose 100, 200, 300, and then after that it doesn't make sense. Even if you increase the number of trees, the error rate is relatively really low. So I would just keep it in 100, and then you could also get the feature ranked by importance, which is the importance it gave to each of those variables while it was trying to predict the random forest on the test data set. So you could also download this table, and it doesn't have a name. We have to rename it. I can just quickly also do that. And then I'm just going to open it with Excel. Yeah, because there was no file extension mentioned, it is not letting to open. So I'm just saying it is safe to open. And also, since we have all these exponential values, it is asking me if I can convert those. And I'm just saying, yeah, you can convert those values. Yeah, this is what you basically get out of it. You can just save it as like this. Even if you do not have this, it is also available in the drive, which also you can use for further sessions. So I guess that's all I wanted to show with the app. The rest we can just play around with it in the session, and we can go around and talk about it. Yeah, I guess that's it from me.